Okay, so now we've created our categorical variable, so as to enter it in as another independent variable, we're going to be doing a two-way between groups MANOVA. Now, one of the issues is that we need, in order to be able to check all of the assumptions appropriately, if you've been looking at the walkthrough, you'll know that we need to have a kind of a noddy variable then, a dummy variable which we can enter in when we're trying to look at things like our VIF and tolerance values, so trying to identify whether we have multicollinearity between the variables. But we can't do that unless we have a dummy variable. So usually what we would use is an ID variable. Now, the authors of the original dataset haven't actually included an ID variable. So we will need to add one. So what we can do is if we go to our variable view, if we scroll down to the bottom, and we can add a new variable, we'll call it ID. We'll leave it as numeric. It doesn't have to have any decimal places, we can get rid of that. And we can just leave it as nominal. In this case, it doesn't really tell us anything. And then if we go to that variable in the data set, we need to give each person a unique identifier. So I actually have created this in Excel first. So we have 178 participants, so I needed a count variable from 1 to 178, which is what I've got here. I'm just going to Control C if you're using Windows. So I'm just going to copy that variable, and I'm just going to go to the first row, and I'm just going to add that in. Okay, so now we've got our ID variable that we need. Now, it's really important to know that we can't be sure that this is actually the order in which the data was collected. So we're only using this to help to check the multicollinearity issue. We can't use it to check things like independence because we really don't know. So if we go to now, if we go to Analyze, and to start with, we're going to have to produce the VIF and the tolerance values using the regression menu in SPSS. So we'd go to Linear. And in our dependent list, we put our kind of dummy variable in. We're not really interested at all in this. What we want to be able to do is to make it run so that we can look at the relationships between our predictors. And if we remember our predictors, our dependent variables in the MANOVA were cognitive well-being, this one, social well-being, and we need to scroll down and find a and then we will click on statistics. What we really want is to produce as well, I'll click collinearity diagnostics. And we click on the descriptive statistics as well, click continue and click OK. And so we've got a few pieces of information. The first thing we want to look at are the correlations, so we get an idea of how our three variables here are related to each other. For a MANOVA to work well, we can have some moderate relationships, up to moderate relationships between these variables. What we don't want to see are strong correlations between any of them. But kind of weak to moderate are, should be okay. And we can double check this, that we haven't got any multicollinearity by looking at our tolerance and VIF values. We're not interested in anything else. So if the VIF value is greater than 10, we would have an issue. Or if the tolerance value is less than 0.1, we would have an issue. So we can see from this that it doesn't look like we have any issues with multicollinearity. And so, okay, that part of the assumption checking has been done. So what we'll also do now is look at producing some information on the traditional way of producing information for normality for MANOVA. Now we have two independent variables for our MANOVA. So what we'll have to do is to start with is to do the split file function. and we'll ask it to compare groups using the sex variable, and then we'll click OK. And so it's going to sort that out for us, and then we'll go to Analyze, and we'll do Descriptive Statistics and Explore, and we will transfer our other independent variable, the median split variable, into the factor list, and then we will transfer over our dependent variables, the cognitive, well-being, and so on. I'm nearly getting there. Okay, so cognitive well-being, social well-being, and then emotional or affective well-being. And we will go to plots, and we'll ask for histograms, normality plots with tests, and click continue, and then OK. And it's thinking about it. Okay, so cognitive well-being and is in the column, the first column. So this is the first dependent variable for males, and for the non-materialistic attainment group. Okay, so we can see that it's splitting it down by our two independent variables for each of the dependent variables. Then what we'd look at are things like kurtosis and skew. And okay, so we can see that there might be some here, something more concerning, whereas this is within plus or minus 1. There's more pronounced skew for this subgroup, and so on. I'll show you the other options for checking the data as well, which is using the residuals, but we'll do that later. And then so you would have a look at each of these, for example. Now this becomes really challenging when you have lots of groups to look at on your dependent variables and subgroups, and so actually moving towards using things like the residuals in the model, the MANOVA, might make life easier for you. But let's go on and do the actual MANOVA then. So if we go to the general linear model, we need to choose multivariate. Oh, before we do that, I forgot. We've got to unsplit the file. So go to Data, Split File, and then Analyze All Cases and click OK. Otherwise, it'll try and produce a MANOVA separately based on one of our IVs, which obviously won't work. So if we go to now go to ANOVA, the general linear model, multivariate. So we want to transfer sex as our first IV, and then our median split variable as our second IV. And then we need to transfer over our dependent variables, cognitive well-being, social well-being, and if we scroll down, emotional well-being there. So we'll go to plots, and I'll ask for a couple of graphs to be produced. So we'll have one where sex is on the horizontal axis, and the lines represent the high and low attainment groups. And then we'll do the reverse of that, and we'll see which one helps us to understand what's going on with the data more. I'm going to keep it as a line chart because I find them easier when you're trying to identify if there's an interaction between variables and so on. And then I'll ask it to include some error bars then. I'll click continue. If we go to post hoc, we don't need this actually because both of our independent variables only have two categories. So if you find a main effect for sex, then it's got to be between males and females in this instance. And if you find a main effect for attainment category, then it's between the high and low categories. But what we will ask for are our estimated marginal mean. So we'll copy all of those. We'll compare the main effects, and we'll click on Bonferroni as well. And I'll click continue. And we'll ask it to produce some studentized residuals, and that's how we'll look at the other way of looking at things like normality. And we can ask it to also produce some Cook's distance scores as well. Click continue. And then options, we want descriptive statistics. We'll ask for some estimates of effect size, and then homogeneity tests. And we could ask for some residual plots as well from there, but I find that sometimes they're quite confusing to try and interpret. So we'll leave it at this for now. We'll click continue, and then we'll click OK. And you can see how the analysis, we've got some descriptive statistics here breaking down each of the dependent variables by, first of all, gender, and then secondly by the median split variable. So the first thing to look at is Box's test. This is, we've got very unbalanced groups, so the fact that we haven't got a statistically significant result here is a very good sign. You can ignore the Box's test of equality of covariance matrices if you've got equal groups, but as soon as you have unequal numbers in each group, this becomes problematic if you violate the assumption. And you violate the assumption if it's less than 0.001, so that's a very good sign. So then we'll look at our Levene's tests. So if we're looking at the Levene's tests, what we've got here, we begin looking to see if we have any p-values of less than 0.05 based on the mean. We don't, so that's a good sign. And so we can start to look at the tests of between subjects effects and things like that. So I'm not going to look at those now. I want you to have a look through them and see what you think of them. We've produced some of our line graphs as well. But have a look at those. Actually, before we do that, I said I'd show you how to check the data assumptions using the other method. So what we're going to do is actually look at Analyze, Descriptive Statistics and Explore. And we're just going to click Reset, because actually what we want to look at now are these studentized residuals on their own without trying to group them in any way. We want to look at the residuals, the studentized residuals, not the raw data. So if we go to plots, we'll ask it to bring up a histogram, some normality plots with tests. We'll click continue and then OK. And this is another way of looking at the data. So what we can see here is that's within plus or minus 1. That's within plus or minus 1 as well, and so is this. So it looks like we've got a very large sample size, really. So if you return a statistically significant result with these, it's not that unexpected. These are massively influenced by sample size. So that looks like it's following a roughly normal distribution. Roughly normal again, it's more, that's definitely more, has a higher peak than a normal distribution, but not too unusual, and that one's got a little bit more skew than a normal distribution. But again, that's roughly normal, and Tabashli will argue that if you've got at least 20 observations in the smallest group, which we have, the smallest group in our example, if we look at our descriptive statistics, is 32, then actually the MANOVA should be fairly robust to moderate violations of normality. So you can see the two approaches to checking the data assumptions, and I think looking at the residuals tends to be a bit easier. But have a look now at the actual findings of the MANOVA and see what you think. And then we will make sure you save this, and we'll look at interpreting the output later. Okay, thank you.